Uh, Ladies and gentlemen, good afternoon. Welcome to ZT Mini Summit. Today, I would like to share our cloud infrastructure evolution solution, which is driven by 5G service. Firstly, I would like to ask all of the guests, let's have an imagination. What happened in the future? What kind of digital life should be like in future in 2020? Okay, here I will give some example, maybe some samples. First sample is that EMBB. It is used for the human digital life. When you take the high-speed train station, if you want to have a service, internet service, such as video service, so how to guarantee the user experience, higher user experience, extreme user experience? According to the research report from NGMN, the data rate should be 20 megabits. It can guarantee the experience for the wide coverage. So when we talk about the hotspot, or when you go to the office, when you go to the studio, how to guarantee the user experience when you want to have an internet service? For example, you want to access VR and AR, how to guarantee the user experience? According to the research report from the NGMN, the average data rate is 100 megabits. The peak data rate is 10 gigabits, maybe more than 10 gigabits. So this is related with human digital life in 2020. When we talk about the IoT, Internet of Things, maybe machine to machine type of communication, how about the requirements for the network? Here is a sample about the low power and MTC. According to the research from the NGMN, in the maybe per square meters, the maximum connection should be 1 million connections. This is a very high requirement for the network, for the 5G network. Maybe for the future, network will be higher. When we talk about the low latency and reliability scenarios, for example, when industry control or e-health scenarios, so according to the research from the NGMN, the latency is less than 1 millisecond, and also 100% reliability. So this in 2020, the digital life has very high requirements for the network. So how to provide the higher requirements based on the 5G network? So let's go to the next slide. Here we can have a summarize. We think maybe not in the industry. We think there are three basic use cases can satisfy the diversified service. First use case is EMBB, involved mobile broadband. It required the high throughput. Maybe just now I mentioned that 10 gigabits, more than 10 gigabits, the data rate. And the second use case is MMTC. That means massive machine type communication. The requirement is maximum connections. It asks the requirements. It asks the network to provide 1 million connections per square meters. This is the second use case. The third use case is URLC. That means ultra reliability, and no latency. Requirement is less than 1 millisecond. So based on the 3 use cases, it can satisfy the diversified service. So we think we have the conclusion that the network should be on demand, should be provide high performance to satisfy many use cases, many scenarios. So just now we mentioned that this is a 5G network target. How to achieve this target? What 5G network should be provide? What features? So here we have some, now today we talk about the cloud infrastructure. So we don't talk about many features in 5G in 3GPP standard. Here I would like to emphasize the SPA. SPA, that means service-based architecture. As you know, in 3GPP standard, there are many features related with 5G. For example, network slicing and COPS. That means control plane and user plane separation, and FMC, and many features. Here I don't want to give many detailed information about this. So here I would like to talk about the SPA. From our understanding, SPA can be maybe more better to combine with container. So our conclusion that microservice and container is the key for the 5G network. So when we talk about cloud infrastructure, what's the requirements for the 5G network? For the cloud infrastructure, we have some conclusion, maybe 3 key points. First key point is high performance. The second point is multiple resource pool. Why we think that is a resource pool? Because you know, in telecom applications, many applications, maybe some application needed to use the bare metal resource. Maybe some applications want to use the virtual machine, but in 5G application ask the network provides a container resource pool. So we think it should be multiple resource pool. This is the second key point. This third key point is that massive, you know, in 5G, it will provide a massive MTC, massive machine type communication. So we think the network is very huge. The connection is very huge. And the terminal is very huge. How to satisfy the huge network? So this is the requirement for the cloud infrastructure. What is the solution? What is the challenge? Okay. Here we give some challenges. How to meet the 5G high performance requirements. We think we need to consider the hardware and software because you know we are talking about the cloud infrastructure. And the second challenge is that how to provide multiple type resource to meet the 5G diversified requirements, service requirements. The third challenge is that how to provide automatic management for 5G huge network. So here we think the intelligence. Maybe we need to introduce the artificial intelligence, machine learning technology to perform the automatically prediction and real-time execution to guarantee the automation. So here's our understanding for the 5G service requirements to the cloud infrastructure. What is the solution? Before I introduce our solution, I would like to introduce our text product. Here is our location, our text product, which is which located in the NFVI and Vim. This is IC NFVI architecture. I think all of you is very familiar with this architecture. So I don't emphasize this slide. I only give the location about our product. Okay. And it includes a virtual VIM, virtualized infrastructure management, and compute, and networking, and storage, and also it includes hardware. So here is only the location about our product. And here, I would like to emphasize our product architecture, why it can fully meet the 5G requirements. So our product provides 6 products. This is different components. First component, I would like to emphasize the text director. Maybe it's not very clear, so I would like to emphasize this product. This product is used for the multiple data center management. Maybe it's not standard in SE. It's not standard in open source. So but we think is very important because it can in charge of multi-data center management, in charge of different type of resource pool management. Maybe it can provide a virtual data center functions. So this is the first product component. The second product is the text OpenStack. It is in charge of virtual machine management, bare metal management. The third product is text OpenPlanet. It's based on the Kubernetes. Yeah, it is used for the container management. And the last 3 product is compute, storage, and network. Yeah, here is our product introduction. And so based on the architecture, we can provide 3 key solutions. So here is a very simple introduction: high performance, and convergence, and intelligent. So here, I would like to emphasize high performance. How to provide high performance? Just now I mentioned that 5G requirements for the low latency, for the high throughput. So how to meet the requirements? More than 10 gigabits per terminal. And here is low latency, less than 1 millisecond. So I divide the latency from terminal side to radio side, and from the radio side to core network. So here, from our understanding, the core network should be less than 0.5 millisecond. How to achieve it? If you use the core hardware, I think it's very difficult. If you want to, maybe you can deploy the core network near the radio side, but it's very difficult. Yes, maybe it is okay, it can be work, but you need to give more efforts. So this is our research from based on the core hardware. So we think we need to perform some acceleration. Here, our solution is that based on the core hardware, we can plug a NIC door card to provide the high performance. We can provide 2 solutions. First solution is to lower the latency. We provide the FPGA NIC, which can lower the latency. And maybe here is our some test data. The latency data figures is less than 100 microseconds. The second technology, accelerated NIC, we think we need to consider the network processing as the NIC because it can provide high performance. So 100 gigabits. But you know, maybe I think most of our colleagues you know, for the core hardware, we think maybe 20 gigabits NIC is used in the industry. Maybe 40 gigabits is used in the industry, but it's not very popular. Only 10 gigabits is used widely in the industry. So how to satisfy the requirement of 5G? Maybe you can put more blade, put more rack server. It's very higher cost. So we propose adopt the dedicated maybe accelerated NIC to increase the performance, to decrease the TCO. So this is our solution based on the hardware optimization. And the second solution is about software. Maybe most of people know this technology. First technology is OS, Open vSwitch. It is very popular in the industry. It was used in IT applications, but for the CT, it's not applicable. Why we think so? Because we have many performance data, and we have already used some in operators reference. It's not used. Maybe it's not applicable. Why? Because for the OS, one blade only 250 kpps. It cannot satisfy CT applications. For example, control plane and user plane. Maybe it can use for the management plane, but it is not useful. So the native OS is not useful. So in the industry, many vendors, many operators want to use the DPK. It can provide higher performance. In addition to this, we think we need to adopt the FDIO. It can increase the performance. We think it can applicable for the 5G applications. So here's our research about the software optimization solution. Okay, let's go to the second solution, convergence solution. In this topic, I want to introduce 3 convergence. First convergence is that NV plus SDN convergence. How to support the NV SDN convergence? What is the key point? And the second, I would like to introduce about the hybrid resource pool, maybe OpenStack, VMware resource pool. And the third, I would like to emphasize the resource virtual machine and container technology and bare metal. So for the last point, I want to emphasize that the enhancement. As you know, the container technology is very popular, very hot in the industry. But do you think it is applicable for the operator, for the CT applications? From ZTE point of view, it's not applicable till now. Maybe we need to perform the enhancement. Maybe some colleagues, maybe some of you know this big point. But here, I only give some drawback or some short mini, some limitation. Okay. Firstly, I would like to emphasize this FSM convergence technology. Here is in left side, it is the architecture, how to convergence the FASDM. I would like to emphasize 2 points. First point, in order to decrease the impact to the next network, impact to the next network. So we propose to adopt the SDN-based VXLAN solution. Maybe it is overlay and underlay architecture because it can have no impact to the next network. The second point that I would like to emphasize, in order to provide high reliability network, we need to adopt the distributed routing and full linkage, maybe full mesh architecture. Why? Because it can provide higher reliability. Why do you think so? Because you know, if you adopt the centralized routing, all of the throughput from north to south, from east to west, the throughput will go to the forwarding node, routing node. This is a single point failure. It is not useful in commercial network, especially in the technical operators network. It will need the viewpoint, maybe a bottleneck of the routing forwarding nodes. So this is our second proposal, to adopt the distributed routing. And additionally, I would like emphasize openness. We need to consider to integrate with the third-party Layers 4 and Layer 7 application service applications components. For example, firewall, VPN, etc. And also, we need to consider the compatible with VML resource pool, because as you know, many operators, maybe there are some legacy equipment, legacy cloud infrastructure. In order to lower the TCO, we need to consider to unified networking. So we need to consider the VML resource integration. This first solution. The second solution is that about the TRL's resource pool. Why? Just now I mentioned for the legacy cloud infrastructure, there are many different resource pool. For example, the VML or maybe Zim resource pool. How to simplify the operation management? We think we need to consider the unified management. Yeah. Here I give the two scenarios. First scenario is that if the traditional or legacy network, there are no resource pool management, we can introduce the text OpenStack to perform the unified management. Where the OpenStack API as the Noteband interface. And the second scenario, maybe it is the virtual data center scenarios. Maybe there are some resource pool management, legacy resource pool management. So how to perform the unified management? So we think we need to introduce the standalone or independent unified management platform, text director, to perform a unified management for the different resource pool. For example, third-party OpenStack resource pool or VMware resource pool. Yeah. For the Noteband interface, we can provide the OpenStack API and virtual data center API. Here's the second solution about the nearest resource pool. Okay, here is a third technology about the container. Maybe, yeah, just now I mentioned that it's very popular. But yeah, because it is wide used in IT, but not in CT. So from our understanding, from the experience, container technology is not enough mature to support CT applications. Why ZT think so? Okay, here I give some, not too much, not too many limitations, only related with networking. Here is a native Kubernetes network. Maybe some of you know this limitation. First limitation that each port only has one IP and a network interface. How to guarantee the security explanation? How to guarantee the reliability? Maybe for the IT, it is not a problem. But for the CT, for the operators network, it is a big issue. This is first issues, first limitation. The second limitation, just now we mentioned that 5G need a high throughput. But for the container and Kubernetes technology, they cannot support the DPK. They cannot support the SRV. We need to perform the enhancement to provide higher performance. So based on this networking limitation, we propose, here is our solution. We adopt the multiple network platforms to support the multiple interface, multiple IP address to guarantee the security isolation, to guarantee the reliability. And also we adopt SRV and DBTK technology in container to guarantee the high throughput, high performance. So this is our solution to enhance the container networking capability. Yeah, here's our, maybe this is our touched architecture from the point of view. We think in the future, the touch network should be mixed or should be hybrid deployment. It includes the virtual machine, bare metal, and container technology. So how to perform the management? I think not only from the ZT side, maybe from the community side, from OpenStack community, from Kubernetes community, we should consider the management, how to manage the different resource pool, unified, not only single resource pool, single management. So here I would like to emphasize 2 points. Unified deployment for the different resource pool, unified management, unified allocation and orchestration for the different resource pool. There. Yes, here is our touch architecture, and also is our ideas. So, just I mentioned that convergence. Okay, let's go to the next point about intelligence. Why we talk about intelligence? You know, the network is very huge. You want to real-time management, how to guarantee this, how to achieve this. I think, it's very difficult because full decoupled architecture from hardware, virtualization layer, and minor application layer, maybe it is fully decoupled. It is horizontal. There's no one to control from all of the layers resource or failures. So how to perform the management, how to guarantee the automation. So here I would like to emphasize the AI and machine learning technology. From the point of view, it includes two procedures. First procedure is that analysis. Analysis. Firstly, we need to analysis to get the knowledge, the library. And based on the knowledge library, and we can perform some automatically execution, server heading, or troubleshooting. Here I give some maybe not too much detailed information. I'll give some general introduction. First step, for the based on the analysis procedure, first step we need to inject some logger, maybe KPI information, and to get and to grab the feature. Here is some example. First example that core events declined, and to perform we adopt some algorithm, machine learning algorithm, and to output the knowledge, and based on the knowledge library, we can in the production network, the operation management, we can configure some policy, monitor policy. Okay, it may be some alarm, how to process it, no problem. You can go to the library to check the library, and then to find the actions, and to do the server heading and troubleshooting, not manually, only automatically. It's done by the machine, not by the operation staff. Here's our understanding for the AI. It can have network operation and management intelligence. Okay. So how to, just now we mentioned that AI is very important. So here I would like to emphasize for the cloud infrastructure, we need to consider the closed loop. From the detection to the monitoring and to do the analysis and to do the automatic execution. Yeah. For the detection, it should be real time. And for the monitoring, also it should be real time. And for the prediction, analysis, you need to adopt some algorithm, some method to perform the intelligent prediction and root cause analysis. So based on this prediction and analysis, we can perform the automatically execution. This is our closed loop logic, how to guarantee the automatic automation, maybe real-time automation, operational management. So in the here I give some example RCA. The full name is that root cause analysis. Yeah, that means you know, just now I mentioned that for decoupled hardware, virtualization layer, application layer, manual layer. Yeah, every layer can produce the alarm, but who knows the root cause? Maybe one blade is failure, but application has alarm, but they don't know the hardware failure. Maybe they think the virtualization layer failure is wrong. So we need to know the root cause analysis. So we need to adopt the root cause analysis. Here I give the, this is our general RCA procedure. Yeah, based on the AI technology. Yeah, it includes two procedures. First procedure is analysis. Yeah. We can, in the operation management, maybe in the EMS, in the VM manager or orchestrator, we can configure the task scheduling and perform the data processing step. It includes several steps. Here I only give the 2 steps, and to extract the information from the data source, maybe from the hardware layer and virtualization layer and application layer and manual layer to get the original data and to perform the clean data. Maybe it's huge data. So how to perform the analysis? We need to clean the data. We need to aggregate data. And then we can perform some algorithm analysis and to perform the data convergence. And that's, based on the machine learning technology, we can output the rules, some rules. Yeah, based on these some rules, when the production network had configured the real-time data alarm monitoring, so how to process alarm, they can get the RCA rules and then perform the execution by themselves. So this is our RCA AI analysis procedure. Okay, based on our solution, here I would give some summaries. Yeah, first summary is that we think future 5G network touch architecture is microservice and containerized, but ZTE cloud infrastructure can provide the enhancement to meet the 5G diversified service requirements. In order to support the city application for the 5G network, we think container and Kubernetes still have a lot of work to do, such as just mentioned the network enhancement, and not only this. We think we need to consider the reliability, performance, and management enhancement. So this is our findings. But ZTE is not only provides a question, also ZTE is a main contributor to open source community. As you know, we are platform of OpenFV and OpenONF and OpenDaylight. And also, we are gold member of OpenStack and DPTK. So we have given many contributions. So For the Kubernetes, for the containers, we will continue to perform the contribution to the open source community. Okay, that's all. Thank you. Any question? Okay.
What is the different taxes, director and money?
In SE, there are different orchestrator. RO, resource orchestrator. I think you can think the RO is the resource. RO is our tax director. Yes, there's difference. You're welcome. Okay, thank you.